Hey again, we're going to pick up where we left off. So in the last video, we calculated this confidence interval for proportion. It was proportion of medical malpractice suits that have been dropped, and so our interval was 0.663 up to 0.731. And then I'm going to go ahead and do this on the calculator. So calculator can do confidence intervals for proportion. What we do is go to Stat, and then for most of the stuff we're going to do for a while, we're going to go to Tests. So we just scroll over to Tests, and then it's an interval for proportion, and so you want to scroll down till it says interval, and we have an interval for a 1 proportion, so 1 prop Z interval, so it's letter A. So I'm going to go ahead and hit enter. And then I put in my value for X. X was 856. That's your count. And then I put in my value for N, which was 1228. My confidence level was 99%. And so I want to change the 5 to a 9 for 99. And then I just hit enter when it gets to calculate. Okay, so this is my confidence interval, 0.663, which is what we got, and 0.731. And this is my value for p hat, 0.697, and my sample size. So that's how you do it on the calculator. How we interpret it is that we're 99% confident, because that was our confidence level, 99%, that the true proportion of lawsuits that have been dropped or dismissed is between 0.663 and 0.731. I usually like to change the to those numbers to percentages, and so I would say we're 99% confident that between 66% and 73% of the medical malpractice lawsuits are dropped or dismissed. Okay, so that's how you do it by hand and also the calculator. And if you remember, the initial question was, does it appear that the majority of suits are dropped or dismissed? And when it says majority, you're looking for 50% or greater. It looks like between 66 and 73% are, so the answer would be yes. Since the interval is above 50%. So just greater than 50%. And a lot of times that's what we do. We see if a particular value is inside or not inside our confidence level. In this case, 50% is outside of our confidence interval. Okay, we're going to skip this section for now. I just want to do more examples with the confidence interval. Your instructor will go over this part of it in class, the sample size part. And so let's do some problems. Now for the margin of error, there's a way to do this on a calculator, but it's really just easier to do by hand. Remember, the margin of error formula is right here. And so we just want to apply this formula to the problem. Okay, so we're on page 57 here. And we want to find the margin of error, and we're given this information. So we need to determine p hat. That's going to be x over n. So 200, that's our sample proportion, over 500. That's equal to 0.4. And then q hat, remember, is 1 minus p hat. And so that's equal to 1 minus 0.4, and that's 0.6. Another thing we need is this 95% confidence. Remember, the table above gives us that value. So 95% is this middle one, so my value is 1.96. That's my value for Z. when I use the margin of error formula. So here's the formula. I use 1.96 for this number right here. Remember, the notation's a bit confusing. Okay, so my margin of error then is going to be equal to 1.96 times 0.4 for p hat times 0.6 for q hat divided by our sample size, which is 500. And that's equal to 0.0043. So that's my margin of error. That's all that's asked for there. And then the next one is a similar problem. We're going to use 0.258 because it's 99%. But my p-hat's given. 25% are successes, so that means p-hat is equal to 0.25. We don't have to do any calculations other than moving the decimal. And so my margin of error is going to be 2.58 because we're using a 99 rather than a 95. Square root of 0.25 for p-hat times 1 minus 0.25, so 0.75, divided by our sample size, so 1068. And that's all under the square root. And that gives me a margin of error 0.034. 0.034 is actually about the standard margin of error. If you ever watch political polls on TV, they usually give a margin of error of around 3%. That's a pretty standard margin of error for a proportion. Okay, so let's go ahead and do the next example. I'm talking about this XORT method. It's a method to increase the probability of conceiving a girl. 325 babies were born to parents using the method, and 295 of them were girls. We want to construct a 99% confidence interval. And then just answer the question based on the results, does it appear to be effective? Okay, so the first thing I want to do, I'll do this by hand, and then we'll go ahead and use the calculator. So I want to calculate p-hat. That would be the proportion of girls born. So there are 295 out of 325. And so p-hat's going to be 0.908. That does seem to be pretty effective. About a little over 90% girls. And then I'm just going to use my formula. I don't have to do the margin of error first, so I'm just going to follow this formula up here for a confidence interval. And I believe I'm doing a 99%, and so I want to use 2.58. That corresponds to a 99%. Okay, so let's go ahead and do it. I take a 0.908. That's my p-hat, plus or minus z value, so 2.58, times the square root of 0.908. And then q-hat, remember, is 1 minus p-hat, so I take 1 minus 0.908. And so that's going to be 0.092. And then I divide by my sample size of 325. Okay, so this is equal to 0.908 plus or minus my margin of error, which is 0.041. And then I'll go ahead and up here, I'll write the interval. So that gives me, if I take 0.908 minus 0.041, that gives me a lower bound of 0.867. and an upper bound of 0.949. Okay, so let's go do that on the calculator. I'm going to stat and then test, and then I scroll down to letter A, which is one prop Z interval. So one proportion Z interval is what we want. And then I put my count in, it's 295. And then my sample size is 325. My confidence level was 99, so I can leave that. And then just go to calculate and hit enter. Okay, so this gives me a confidence interval of 0.866 up to 0.949, which is pretty similar, a little bit of rounding error, but no big deal. Okay, and so let's answer the question and interpret the confidence interval. So we can be 99% confident that the chance of having a girl using the XORT method is between 0.867 and 0.949. Because these numbers are so high, because this probability, remember, it's about a 50-50 chance when you don't use the method of having a girl. It appears that XORT works. Okay, so I can interpret that as the percent of girls born for parents using the XORT method. Because these numbers are so large, much better than a 50-50 chance, it does appear that the method is working. All right, let's go ahead and do one more example. That's about all we'll have time for in this video. So let's do the last example in your notes for this section. It says in a Gallup poll, 595 of the 1,009 adults said they wanted to lose weight. And so the percent of the sample that wanted to lose weight, that's your sample proportion or your p-hat. And so that's going to be your value for x. Sorry. That's going to be your p-hat, which is going to be, oops, stop that. We'll put it over there anyway. All right, sorry. So that's going to be 595 divided by 1,009. So that's a sample proportion, and that turns out to be 0.590. Find a 95% confidence interval for the proportion of the population that wants to lose weight. So I take my value for p-hat, which is 0.590. If you look at the table above, a 95% means that I use the value 1.96. So I take 1.96 times 0.590 for p-hat times 1 minus that. So 1 minus 0.59 is 0.41. And then I divide by my sample size. And so this is 0.560 up to 0.62. Okay, so real quick on the calculator, I go to stat and then test and then scroll down to letter A. and enter. Then my count would be 595. My N is 1009. I change this to 95, and then I just hit calculate. And it gives me 0.559 up to 0.620. About 0.560 up to 0.620. So about the same. Okay, and all right, just the last question. Suppose a nutritionist claims that 73% of adults want to lose weight. Is this number possible based on the confidence interval? So let's interpret the confidence interval first. We are 95% confident that between 56% and 62% of adults want to lose weight. Therefore, it appears that the percentage is lower than 73%. So we're just answering whether or not 73% is a plausible number based on the confidence interval, but our confidence interval goes between 56 and 62, so 73 is outside of that bound. All right, see you next time.